All right, so we're going to do this last lab a little bit differently. I've kind of done most of the setup here already. We're only going to do one trial just because you don't need to watch me do the same thing 3 times. Yes, we would usually do multiple trials just to verify our results, but since we are doing this in my garage and not an actual lab, there's enough other sources of error anyhow. The first thing that the lab has you do is to prepare a approximately 0.1 molar sodium hydroxide solution. So you do the calculation, what mass of sodium hydroxide would you need to get 500 milliliters of the 0.1 molar solution. If you read the procedure, it says to dissolve that sodium hydroxide in about 100 milliliters of water in a 500 milliliter volumetric flask, and then add enough water to get up to the 500 milliliter mark. Again, that's just because when we dissolve stuff in water, that does change the overall volume. So we don't want to have 500 milliliters of water and then add the sodium hydroxide because that will change the volume overall. So by dissolving it in the 100 milliliters first and then diluting it, we end up with exactly 500 milliliters of solution, which is the definition of the molarity. So I already made that sodium hydroxide solution. I've got it all mixed up. It's already in the burettes. The first thing that we have to do is calculate the concentration of that sodium hydroxide. Now, it should be about 0.1. The problem is no matter how accurate our measurements are when we're measuring out the mass of the sodium hydroxide will actually absorb water vapor from the air. So because of that, when we are finding the mass of that sodium hydroxide, we have some water molecules in there and we don't know exactly how much. So no matter how careful we are, we don't know exactly what that concentration of sodium hydroxide is. So the first thing that we're going to do is figure that out using a titration of KHP, which is potassium hydrogen phosphate. Looking at the directions, it said to have it in the oven because KHP does also absorb water vapor from the air. So remove it, let it cool in a desiccator for 20 minutes. Well, I have my food oven, but I'm not putting chemicals in there. So I don't have the oven, I don't have a desiccator either, so already we have lots of error introduced into this, but we're just going to pretend that that was done, and if we get weird answers, this is why. So it says weigh between 0.4 and 0.5 grams of the dry KHP. Again, we don't know if this is dry, but we're going to pretend. I weighed out 0.5 grams of KHP. So record that in your data table. And again, we're only going to do one trial. And then it says add approximately 100 milliliters of distilled water to the flask and swirl it to dissolve the KHP. I've already done that. The exact amount of water doesn't matter here. We just need to be able to dissolve the KHP. And we're not trying to find the concentration of the KHP solution. We know what mass we use, so we know how many moles of H plus are in there. So I've already dissolved the KHP. I've also added the phenolphthalein. And it says we're going to titrate this with the base until the first pink color of the indicator persists for 30 seconds. So we are going to add this when it gets the right pH for the phenolphthalein to turn to pink. That pink will stay. We want it to be as faint of a pink as possible, but we want that pink to stay because when I add the NaOH, sometimes that will cause it to turn pink in one location, but once we swirl it around and let the reaction take place, it's all reacted away and we haven't actually reached that end point yet. So to do that, the first thing we need to do is record the initial NaOH volume from the burette. You might remember from last year that 0 is at the top of the burette, and these go up to 25 milliliters. So if I look here, I'm between the 0 and the 1, so I have 0.8 milliliters. We are measuring what's been let out of the burette already. So that initial volume of NaOH, we're recording as 0.8 milliliters. All right, and then we're going to come down and all right. Let me try and make this so that you can see it a little bit better. So you can see there's a little bit of pink there, but when I swirl it to let the reaction take place, it all disappears. Okay, so we are down to the 25 milliliter mark on this first burette. So final volume in burette we're going to write as 25, but we're still not to that persisting pink color yet. So we're going to fill up the burette again. And actually I have a second one filled here ready to go. And we're going to look at the top here again, and we are at 0.7. So my second one starts at 0.7. And we're going to bring this so that you can see it hopefully. So the longer it takes that pink color to disappear, the closer we're getting to it staying, because it's taking longer for the KHP, the H plus, and the OH minus to find each other to neutralize. And, all right, that pink color is definitely persisting. Probably went a little bit too fast toward the end. But if we come up and look at the burette, if I can find it with the camera. All right, so it is at 19.8. So when you go to find how much sodium hydroxide was added to this solution, you are going to take that 0.8 to 25. So there was, 24.2 added from the first burette, and then the 0.7 to 19.8. So 19.1 added from the second burette. Add those two numbers together for the total amount of sodium hydroxide that was added to this flask. All right, so the next thing that we're going to do is to find the concentration of an HCl solution, which I have in this flask. I'm going to have to refill my burette first. So you're going to need to do the math and calculate what the concentration of the NaOH solution actually is based on the data that we got with the KHP. Once we have that, we know the volume of HCl. In this flask, I believe it told us to put in 25 milliliters, which I did. So I've got 25 milliliters of HCl. And we don't know what the concentration of the HCl is in this flask. And then we're going to let some sodium hydroxide out of the burette. We, once you do the calculation, do know the concentration of the NaOH, and we will know the volume that we added as well. And we'll use that to find the concentration of the HCl solution. So I have added the phenolphthalein in as well. I have this burette. It's actually filled up right to the 0 mark, which will make things a little bit easier. But the volume of the HCl that we used, again, is 25 milliliters. And the initial volume of NaOH in the burette is 0. So now we're going to start adding the NaOH. That will drop on the side too. All right, and we've got that persisting pink color again. So we know we've finished this reaction. And if we, where did the burette, there we are. If we look at the burette, it is at 19 milliliters. So our final volume of NaOH is 19. And since we started at 0, that's just going to make the math a little bit easier. We added 19 milliliters to it. One of the nice things about doing 3 trials is not only you get better data, but also, like I said, we want the faintest pink possible. You can get a fainter pink than this. So if we did multiple trials, you kind of know really when you're getting close to the end point, and it goes a little bit quicker, and you can be a lot more careful with the last couple drops and potentially end up with that really faint pink color, which would give us more accurate results. All right, the last thing that we're going to do is determine the concentration of vinegar, which I have some vinegar put in here. If you read the procedure, it said we added 2 milliliters of vinegar to this flask and then added about 20 milliliters of water to it. So we only wanted to use 2 milliliters of the vinegar. So the volume of vinegar that we used is 2 milliliters. Now there's more than that in the flask right now because I diluted it with water. But we're looking for the concentration of the vinegar, not of this dilute solution. Essentially, we diluted it just to give a little bit more volume so that we can see that pink a little bit better. If we just had 2 milliliters sitting in the bottom, it would be a little bit harder to see that. So again, I filled this burette up to 0, so that initial NaOH volume in the burette is 0. And then I'm going to start adding the base. And as you can see, I definitely did put the phenolphthalein in there already. Try and get that a little bit on the side. All right, and we've got that pink color, and on the burette, we can see that it is 16.3 milliliters. So that is our last step. Everything that's left is just calculating those concentrations. All right, so I will talk to you later. Bye.